Hello and welcome back to Dataverse by Ninopol. I am fully charged and ready to go today because we are tackling a subject that influences your life probably, 3 or 4 times a week, and you usually don't even notice it's happening.
Chuckles. That's so true.
We are officially on episode 14, and today we are breaking down the science of market basket analysis.
It is great to be back. And you are spot on. This is one of those topics where data science crashes right into human psychology. It's the math behind why you buy what you buy.
I love that. So to kick things off, let's get everyone on the same page. I want you and everyone listening to just visualize your last trip to the grocery store.
Okay.
You run in, swearing you're only going to grab a box of penne pasta. That is the mission. But then you're standing there, and right at eye level next to the pasta is that premium marinara sauce. And 2 feet down, a block of Parmesan.
And suddenly the mission parameters change.
Completely. You walk out 5 minutes later with the pasta, the sauce, the cheese, maybe a frozen garlic bread loaf, and you feel good about it. You feel like, wow, I just had a great idea for dinner. But here is the reality check I learned from prepping for this deep dive. That wasn't my idea, was it?
Not entirely, no. That natural flow you felt, that was engineered. Retailers aren't just guessing that you might be hungry. They are using historical data to predict the exact combination of items that, just make sense to you in that moment.
The sources for this deep dive dropped a statistic that actually made my jaw drop. It really puts the scale of this into perspective. We're talking about Amazon.
We are. Yeah. According to the McKinsey report we analyzed, over 35% of Amazon's revenue comes from their recommendation engine.
35%.
Think about that. More than a third of what people purchase on one of the world's largest platforms is the result of an algorithm suggesting, if you bought this, you might also want that.
That is wild. That's not just a nice-to-have feature. That is like the backbone of their business model.
Yeah.
So our mission today is to decode that backbone. We aren't just looking at the surface level. We want to understand the mechanics of market basket analysis, how the algorithms actually think, the specific metrics they use, and why this is about more than just selling us extra cheese.
It really is a mind-reading technique in a way.
Yeah.
But let's strip away the buzzwords for a second. What are we actually talking about here?
Let's get technical.
Yeah.
What is the definition?
At its simplest level, market basket analysis is a data mining technique. But here is the crucial shift in perspective. Traditional sales reporting, it looks at products in isolation.
Okay.
It asks, how many cans of soda did we sell? Market basket analysis looks at the transaction as a whole, the basket.
So instead of focusing on the item, it focuses on the relationship between items.
That's the key. The question shifts from how much did we sell to when a customer throws product A in the cart, what is the probability that product B follows it? It treats purchasing behavior as a web of connections, not a list of independent events.
And I assume this is happening everywhere. I feel it most online because the website literally tells me customers who bought this also bought. But this is old school retail tech too, right?
Oh, absolutely. It started offline. In brick-and-mortar stores, analysts run these models on point-of-sale data, your receipt data.
Right.
And that informs the physical architecture of the store. If the algorithm proves that peanut butter and jelly are statistically inseparable, you don't put them in different aisles.
Unless you want to annoy your customers.
Exactly. You put them side by side to reduce friction.
And then online, they have even more data. They aren't just looking at the receipt. They're looking at what I clicked on, what I put in the cart, and then removed.
Correct. That clickstream data feeds recommendation engines that power those you might also like widgets. It's all about uncovering patterns to inform everything from bundle offers to layout design.
Okay, so the concept is intuitive. People buy things in groups. But I know our audience likes to look under the hood. The reading mentioned association rules. This sounds a bit like a secret society, but I gather it's the math that makes this all work.
It is.
Can we break that down without needing a whiteboard?
We can. So in data science, when we run these algorithms, like the famous a priori algorithm or FP growth, we are looking for these association rules.
Okay.
They are essentially if-then logic statements.
Yeah.
If you buy pizza dough, then you probably buy pizza sauce. But you can't just guess. To prove a rule is strong enough to act on, we use 3 specific metrics: support, confidence, and lift.
Okay, let's walk through these because this is where the magic happens. First one, support. This one seemed pretty straightforward to me.
It is. It's the foundation. Support just measures frequency. It asks, out of all the transactions we process today, what percentage contain this specific combination of items?
So it's a popularity contest.
Essentially, yes. High support means a lot of people are buying that combo. If 10% of all shoppers buy chips and salsa together, that's your support. It filters out the weird one-off purchases that might just be a fluke.
Got it. So we know people buy them, but knowing they're bought together doesn't tell us how strongly they are linked. That's what confidence comes in, right?
Correct. Confidence is about predictive probability. And this is where direction matters. It asks, given that a customer has already committed to item A, how likely is it that they will pick up item B?
That direction part is interesting, because I imagine if I buy a laptop, I'm very likely to buy a mouse. But if I buy a mouse,
You're not necessarily going to buy a laptop. The confidence might be, say, 80% in one direction, laptop to mouse, but only 5% in the other. This tells the retailer where the leverage point is. You discount the laptop to sell the mouse, not the other way around.
Okay, I'm with you so fair. Support says this happens often. Confidence says if this, then that. But then we get to this third metric, lift. And I'll be honest, when I first read about this, I thought, do we really need a third metric? If I have 80% confidence, isn't that enough? Why does lift exist?
This is a great question, and it's where a lot of rookie analysts get tripped up. Confidence can be misleading because it doesn't account for the baseline popularity of an item.
Give me an example.
Okay, let's imagine a grocery store. What is the most common item people buy? Let's say it's milk. And let's assume 50% of all customers buy milk every single trip. It's just a staple.
Okay, so milk has high support on its own.
Huge support. Now let's look at people who buy, I don't know, light bulbs. You run the numbers and find that 50% of people who buy light bulbs also buy milk.
Right.
That gives you a confidence of 50%. That sounds high, doesn't it?
It does. It sounds like half the people changing a light bulb suddenly crave calcium.
But look at the baseline. 50% of everyone buys milk. The people buying light bulbs are just acting like average shoppers. There is no special relationship there. The fact that they bought bulbs didn't increase their likelihood of buying milk at all.
Ah, I see. So the connection is an illusion caused by how popular milk is.
Precisely. That is what lift measures. It compares the confidence of the rule against the expected confidence if the items were totally independent.
So if lift is 1, it means...
It means there is no relationship. It's just random chance. But if lift is higher than 1, it means the two items are actually attracting each other. Item A is driving the sale of item B.
So in the light bulb example, the lift would be exactly 1.
Exactly 1. But if we looked at cereal and milk, maybe 90% of cereal buyers get milk compared to that 50% baseline for everyone else. That's a massive positive lift. That tells you the relationship is real.
That is a crucial distinction. It effectively weeds out the coincidences so you don't build a marketing campaign around a correlation that doesn't actually exist.
It saves retailers from some pretty embarrassing mistakes. You want to bet on high lift, not just high confidence?
So once the math has done its job and identified these high lift pairs, how does that translate to the real world? We talked about pasta and sauce, but the sources gave some other examples that show how this taps into different types of customer logic.
The logic varies by industry, which is what's so fascinating. In grocery, like we said, it's about meal solutions. But think about fashion retail.
Outfit building.
Right. In apparel, the connection is aesthetic. Market basket analysis identifies that a specific floral shirt has a high lift with a specific beige belt.
Which explains why when I click on that shirt, the model in the picture is wearing that exact belt and there's a button saying shop the look.
It's acting as a digital stylist.
Yeah.
And honestly, it's helpful. But in electronics, the logic shifts again. It's not about aesthetics. It's about, functionality and necessity.
The upsell or the complete solution.
Think about buying a high-end digital camera. You buy the body, but you need a lens, you need an SD card, you probably need a carrying case.
And if you don't buy them right then, you get home, open the box, and you're just frustrated because you can't actually use the thing.
That's the point. A lot of people think upselling is just greedy, trying to squeeze more money out of your wallet. But if the retailer uses the data to bundle the SD card with the camera, they are actually preventing post-purchase dissonance.
Right.
They're ensuring you have a working product. It actually improves customer satisfaction.
So the algorithm is essentially trying to reduce friction. It's trying to say, hey, you're going down this path, here's the gear you need for the journey.
Paving the desire paths. That's exactly what it is.
Now, we focus a lot on selling more stuff, increasing the basket size. But the readings suggest that market basket analysis plays a much more strategic role in how a business is run beyond just the checkout page.
It does. It informs the actual architecture of the business. Take store zoning or layout planning.
This is the physical arrangement of the aisles.
Yes. So if you know that printer ink and printer paper have a massive lift, you have a choice. You can put them next to each other for convenience,
Hmm.
or you can put them at opposite ends of the aisle to force the customer to walk past the staplers and the pens.
Oh, sneaky, the IKEA effect. Make them walk the path.
It's a balance, but the data tells you where the heat is. It also helps with category management, deciding what to keep in stock.
How so?
Well, usually retailers cut products that have low sales volume. But what if there's a niche item, say a very specific type of gourmet cracker, that doesn't sell often, but whenever it is sold, the basket size is huge?
Like the people who buy that cracker also buy $200 worth of wine and cheese.
Exactly. If you just looked at volume, you'd fire the cracker. But market basket analysis tells you that that cracker is a basket driver for your high-value customers. If you cut it, you lose those big baskets.
That is super smart. It protects the items that are bringing in the whales. And speaking of types of customers, there's a point about segmentation that I thought was really powerful. Usually we segment people by who they are, age, zip code, income.
Which is, I mean, it's becoming outdated. Demographics are kind of a blunt instrument.
Right,
Market basket analysis allows for behavioral segmentation.
right. My neighbor and I might be the same age and live on the same street, so a demographic model just treats us the same.
But you might be buying frozen pizzas and soda, and your neighbor is buying kale, quinoa, and salmon.
The Bachelor bundle versus the Health Kick bundle.
The data sees that. It doesn't care how old you are. It cares about the lifestyle revealed by your cart. And that allows the retailer to send you a coupon for wings and your neighbor a coupon for organic yogurt. The relevance goes through the roof.
And the payoff for getting this right isn't pennies. McKinsey says personalization based on this data can drive a 10 to 15% revenue lift.
Yeah.
In retail, where margins are razor thin, that is the difference between keeping the lights on and expanding.
It's massive.
Yeah.
But, and there's always a but in data science, it is not as easy as just pressing a button.
I was going to ask, if this is a gold mine, why isn't every store perfect at it? Why do I still get recommended cat litter when I've only ever bought dog food?
The cat litter paradox. It happens because of several pitfalls. The first and most boring one is simply data quality.
Garbage in, garbage out.
Always. To get the deep insights, like knowing you are a dog owner versus a cat owner, I need to link your transactions over time. I need a loyalty ID or a login. If I just have a pile of anonymous receipts, I can't build a profile. I just know someone bought dog food. I don't know it was you.
So without that loyalty link, the system has amnesia every time I walk in.
Correct. Then there is the spurious correlation trap. We touched on this with the milk, but it can get weirder. Sometimes the data shows a correlation that is statistically significant, but, practically useless.
The classic example is toothpaste and apples, right?
Right. Maybe people buy them together frequently because they run out of both at the same rate. But if I bundle them together, buy Colgate, get a Granny Smith free.
It just sounds disgusting.
It makes no sense. The algorithm sees a number, but it doesn't understand context. You need a human in the loop to say, no, don't put the bleach next to the baby formula, even if the numbers look interesting.
Then there's the organizational side, the silos. This one feels like a classic corporate headache.
It is the biggest hurdle for large companies. You have the analytics team, who are the wizards finding these patterns. Then you have the store operations team, who actually have to move the shelves around.
And the ops team probably hates moving shelves.
It's heavy lifting.
Yeah.
Literally. If the analytics team says, move the diapers next to the beer, the store manager might say, that disrupts my layout, I don't have space, and it looks weird. If those teams aren't talking, the insight dies in a spreadsheet.
So you can have the best math in the world, but if the culture is broken, it just doesn't matter.
Spot on.
So for the retailers listening, or just anyone interested in how this is done right, what are the best practices? How do you avoid the silos and the bad data?
I think you have to start with the right mindset. Don't just mine the data, hoping to find gold. Start with a business question.
Like, how do we sell more accessories?
Right, or why are our morning baskets smaller than our evening baskets? Define the problem, then ask the data. And you have to test and learn.
Experimentation.
If the model says pasta and sauce go together, don't roll it out to 500 stores on day one. Change the layout in 10 stores. Measure the lift against 10 control stores. Prove the value. That is how you convince the store ops team to move the shelves. You show them the money.
They're looking forward. Where does this go? We have apps. We have smart carts. Is the future just faster algorithms?
It's speed and integration. The holy grail is real-time AI.
Meaning the recommendation changes while I'm looking at it.
Exactly. Imagine you are online. You put a tent in your cart, Before you even click checkout, the AI analyzes that action, looks at the weather forecast for your area, maybe your past purchases, and instantly creates a dynamic bundle. Add this sleeping bag and flashlight for 15% off right now.
So it's negotiating with me in real time.
It's anticipating needs based on live context. And in physical stores, we're seeing smart shelves, digital edge displays that can change pricing or highlight complementary items based on what you pick up.
It feels like the store is becoming a living organism.
That's the trend. And with voice commerce, Alexa, Google Home, the input data changes. How you ask for dinner ingredients might reveal different patterns than how you browse for them. It's a whole new data set to mine.
It's fascinating and a little terrifying, but ultimately it comes back to that idea of utility.
That is the big takeaway. Yes, market basket analysis makes money for the retailer. But when it's done well, it saves time for the consumer. It creates a seamless experience where the store, whether it's physical or digital, seems to know what you need before you remember it yourself.
It turns a chore into a flow state.
Ideally, yes.
Well, I will certainly never look at a recommended for you widget the same way again. I'm going to be wondering about my Lyft score.
As you should.
I want to leave you all with a thought. Next time you are shopping and you find yourself grabbing an item you didn't plan on buying just because it was conveniently placed, take a second. Ask yourself, was that impulse? Or was that a prediction made by a machine that knows your habits better than you do?
It wasn't luck. It was math.
Thanks for diving in with us on Dataverse by Nina Pohl. Keep questioning the data.
Until next time.